In the previous video, we talked about congruent figures. Remember it, right? Can you tell me what they are? Yes, they are figures having the same shape and the same size. We ended our last video with this one question. What if two figures had a common base? And what if they're placed between the same parallel lines? Let's see what happens. Have a look at these figures. Look closely at the first figure. Can we say that the trapezium ABCD and the parallelogram EFCD have a common base? Yes, we can. And what is their common base? Yes, it's CD. Similarly, have a look at the second figure. Do the parallelograms PQRS and MNRS have a common base? Yes, they do. And their common base is SR. Now have a look at the third figure as well. The triangles have a common base, which is BC. But do they lie between the same two parallel lines? Not really. Now have a look at these figures. Let's look at the first figure. Do the parallelograms PQRS and MNRS have a common base here? Yes, they do. The common base here is SR. There's something more as well. Look closely. The vertices P and Q of parallelogram PQRS opposite to the common base SR and the vertices M and N of the parallelogram MNRS, which is also opposite to the common base, lie on the same line. Hence, we can say that the two parallelograms PQRS and MNRS have a common base SR and these two lines are parallel. Similarly, even in the next figure, the two triangles have a common base BC and lie between the line AD and the common base BC. Let's assume AD and BC are parallel to each other. But what can we say about the areas of the two parallelograms or the areas of the two triangles in these cases? Will they be equal or will they have some other relation between them? The areas of these two parallelograms will be equal and the areas of these two triangles will also be equal. Why do we say that? Watch our next video to know more.